This video is on titrations and titration curves. So a titration is set up where we have a stand. It's a ring stand. And a ring stand is set up and we set an Erlenmeyer flask. And inside the Erlenmeyer flask, we put an analyte and an indicator. Purpose of a titration is to use some sort of liquid of known concentration, which is a titrant, into a burette, and you're going to put some of this into our unknown concentration solution, which is an analyte, to be able to determine the pH of or concentration of our analyte. So this top apparatus is called a burette, contains our titrant. We have our Erlenmeyer flask, which contains the analyte and the indicator. And we put our titrant, goes down into our analyte and the indicator, and this will change colors depending on the pH. So, a controlled addition of titrant used to determine the concentration of an unknown is a titration. So that's what this is. We use a titrant to titrate an analyte. The analyte is what we're analyzing. So, into the burette is the titrant. That's what you do your titration with. The solution of known concentration is the titrant. Again, you do a titration with a titrant. So this is known concentration. The solution of unknown concentration is your analyte. So it's your unknown concentration. The point when an indicator changes colors is known as the endpoint. So we would do our titration until our analyte changes colors, which is really the indicator that changes colors. And that would tell us that we are done. We've changed it to the pH. And then we will record the volume of burette used, the volume of the titrant used, and how much analyte we have and its concentration. A weak acid or base that changes colors when the pH changes is called an indicator. And we know that we're done. The equivalence point is when there are equal concentrations of hydrogen ions and hydroxide ions. And we will do a version of this. The data you collect from doing a titration gives you a titration curve where we have our milliliters or our volume of titrant added, and then we can graph the pH associated with how many milliliters we've added. And that's dependent upon the color of our analyte. If we look at our titration curve, we have this point of inflection where it goes from being a positive slope to a negative slope. This usually falls around a pH of 7. And if we read down, we would get our volume. This is called the equivalence point. It's the point where there's equal concentrations of acid and base, which means that the acid and base are going to cancel each other out and it's going to be a neutral solution. Anything from just below 7 to 0 is going to be acidic. And any solution above 7 is going to be basic. So we can read on our graph that we still have an acidic solution until we've reached our equivalence point. At our equivalence point, we are neutral. And then after that point, we become a basic solution.